Okay, so in this video, we're going to look at question 4, and we are going to prove what they're asking. And this is definitely the hardest one out of the 4 storytelling problems. And this question is on page 8. So it says, in the figure, ABCD is a parallelogram, triangle AJD is isosceles with vertex D, and triangle CBI is isosceles with vertex B. And it says, write a story to show that angle ADJ, so that's this angle, and angle CBI are congruent. Okay. And so we don't really need this figure at all. They don't tell me anything about that figure. It's just kind of extra. And the other thing is, don't start with what you know is congruent. You need to prove that that is congruent. So our goal is to show that this is equal to this, but I can't start with that. And usually we try to start with one of those angles, ADJ, but I can't relate ADJ to anything else right now in this figure. Like it's not equal to anything in this parallelogram that I know of. I don't have a way to figure out this angle because I don't have measures. So I kind of have to start somewhere else with this one. So we can start with AJD is isosceles, which means these two sides are equal. And if we start there, we do know for an isosceles triangle that the base angles are congruent. So we can start with like angle DJA is equal to angle DAJ, since base angles of isosceles triangle AJD are congruent. And so I'm going to mark that. And if you don't know where to start, like I said, I would just start with like something you know. Okay, so I know that. And I want to be able to like work my way over and get to angles in this triangle. So I know that because we have a parallelogram, AB is parallel to DC. And therefore, I know if I think about it, this AB is like this transversal. And therefore, I have these angles which are alternate interior. And so they are also equal. So we can add that and say that next. So since ABCD is a parallelogram, AB is parallel to DC, and angle, let's see, J, I'm going to stick with what I had. So DAJ is congruent to angle ADC since they are alternate interior angles. I'm going to check. Since alternate interior angles are congruent. Because the lines are parallel, so we have to know that part. Okay, so right now I have, okay, DAJ is equal to ADC in that parallelogram. And I still need to like get over here. So I'm thinking, okay, what can I relate this angle to? Well, I know that angle ADC is equal to angle ABC since opposite angles of a parallelogram are congruent. Okay, so I know those are congruent, and I'm not putting the congruent symbol since I'm typing it, so it's easier to read. I would put that, I can add it back, but these are all, we're actually saying congruent. All right, so we know that. So if I mark that in my diagram, we know that this is congruent. Okay, so how does that help me? Well, therefore, I know that this, I can relate that to a triangle because again, I have these parallel lines A, B, B, C. I have this line, which is that transversal, and I again have these alternate interior angles. So I can say now, Okay, so angle ABC is congruent to BCI since AB is parallel to DC and alternate interior angles are congruent. Okay. And then kind of the last thing, well, okay, I know that angle is equal to this angle because again, we have this isosceles triangle. They told us that triangle is also isosceles and the base angles are congruent. So angle BCI is congruent to angle BIC since base angles of isosceles triangle CBI are congruent. Correct. And so pretty much what we really showed, and if we kind of go back, is we showed that this angle DJA is equal to BCI, and we showed that JAD is equal to BIC. So we have these like base angles congruent. So I'm going to state all of those are congruent. So angle DJA is equal to angle DAJ, which is equal to angle BCI, which is equal to angle BIC. So I'm just stating that these four angles, this angle, this angle, this angle, and this angle are equal by substitution. Okay, we showed some of them already, but I'm just saying that all of them are equal by substitution. And how does that help me? Well, now I have two triangles with two congruent angles, which means that that remaining angle has to be equal since the three angles add up to 180. So if these two angles are equal to these two angles, then this remaining angle has to be the same as that remaining angle. So what we can do then is kind of write the triangle sum formula. We can show that those three angles are equal. So we could say ADJ plus DJA plus DAJ equals 180. This is the triangle angle sum. And then we can say that angle BCI plus, sorry, I want to do the same order. So I'm going to start with the vertex angle because that's what I started with in the other one. So angle CBI plus angle BCI plus angle BIC equals 180. Okay, so again, I'm just stating the three angles in each of these triangles equal to 180. I'm just matching it up with like the order that I had in the statement and the order that I put the angles throughout my proof so that it matches up. Okay, and then the last thing is, well, I know these are equal. Nope, sorry, that's what I'm trying to prove. I know that these two are equal because I'm saying it up here. DJA is equal to BCI. I know that DAJ is equal to BIC. And so again, if those two are equal and these add up to 180, these also have to be equal because that's what's left over. So therefore we know that angle ADJ is equal to angle CBI or congruent. And we usually say again by substitution, and it would also be elimination. I am eliminating these two, and then I'm substituting that these are equal and these are equal, and then I'm eliminating those equal angles to get these two to be equal. Okay, so we didn't really show like all the work in the last step, but it's already long enough, so that's good enough for the proof. This is definitely the hardest one, so don't freak out if you can't fully get it. Make sure you know how to do like 1 and 2 and then the ones on the homework. And if you have any question, let me know.